Let us start our second chapter, relations and functions. In the first chapter, we were discussing about sets. Actually, this chapter is a continuation of first chapter. In the first chapter, we had seen different types of sets and distribution of elements of sets, power set, superset, subset, etc., etc. Isn't it? So the same things are again, we are discussing again these type of terms once again. For that, before starting this chapter, let us introduce once more the term set, and I am taking a set with the name capital A. It's a set 1, 2, 3. It's a finite set, isn't it? Number of elements in this set is finite or countable, isn't it? Another set B is equal to set 4, 5. Number of elements in this set is 3. 1, 2, 3 elements. We know that elements, these are elements, isn't it? This is name. Name of this set is capital A. Usually, name of every set is described by capital alphabets. Okay. And another set B, there are two elements, 4 and 5. Using these two sets, I am describing a particular pattern like this. You see here, 1, 4, a particular type of distribution of elements of these two sets. 1, 4, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5. Okay. So distribution of elements, this pattern is very simple. Firstly, we are taking first element of the first set, that is 1, then mapping for or combining this 1 with this 4, 1, 5. That is all about this one. Then 2, 4, 2, 5, okay, 3, 4, 3, 5. And this type of expression is denoted by this symbol. Usually it is read as A into B, but that is not correct. It is read as A cross B. A cross B, isn't it? So A cross B. When we define A cross B, first we start with the elements of first set A. If it is B cross A, then you have to take first element from this B and second from A. Then what will be B cross A? B cross A is what? 4, 1, set 4, 1, 4, 2, 4, 3, isn't it? 4, 1, 4, 2, 4, 3, then 5, 1, 5, 2, and 5, 3. So this is the difference between A cross B and B cross A. What about the number of elements in A cross B? What about number of elements in A? Number of elements in A is 3, n of A. N of B, number of elements in B, 2. Okay. Number of elements in A cross B. Here this is single element, 1, 4. Okay. This comma is very important. 1, 4, 1, 2, 3, 4, 5, 6. Then how do you define a formula to find number of elements in A cross B? Number of elements in A cross B is equal to number of elements in A into number of elements in B, isn't it? That is n number of elements in A cross B. That is why we are taking this type of symbol here, cross or into symbol. Because number of elements in A cross B is obtained by multiplying the numbers of elements of these two sets, capital A and capital B. Uh, the number of elements in A cross B is n of A cross B equal to n of A into n of B. Clear? So now we have introduced a new term which is called as what? Cross or cross product. A cross B. It is written as A cross B. This type of distribution or expression is used to identify a particular point in a graph. Usually, we have seen in your lower classes when we draw a graph, it is its middle point 0. Along x-axis, we are taking 1, 2, 3, etc. and minus 1, minus 2, and so on. 1, 2, 3, minus 1, minus 2, minus 3, and so on. This is very similar or familiar. Okay. Then, now I am marking a point here, this point. What about this point? Here, x-axis number. Its x-axis number or x-coordinate, that is 1. 1. Its y-coordinate is what? 3. So the point is 1, 3. Like this. Here 1, 3 is not possible from here. Similarly, let us take 3, 4. This is 3, 4. 3, 4. Here x coordinate, coordinate. X coordinate of this point is 3, y coordinate is 4. 3, 4. Okay. So we use this type of expression for denoting particular points on a graph. This system was introduced by a French mathematician named René Descartes. And therefore this system of representation is called what? Cartesian product. Cartesian product. Cartesian product. So this system is represented by the term Cartesian with this name Descartes, Cartesian product. Or this graph paper is called as what? Cartesian plane. Okay, anyway, leave it. So this A cross B, 1, 4, 1, 5, 2, 4, 2, 5, this can also be named as what? Cartesian product. Cross product, cross product, cross product or Cartesian product. So what do you mean by Cartesian product? A cross B. This system was introduced by René Descartes and his name is used here to identify particular point on a graph paper. So anyway, in this chapter we are dealing with the term A cross B. So you just note the representation of A cross B. When you are given two sets A and B, when you are asked to find A cross B, first you list out elements of A, then B. Then starting from A and ending at B, A cross B can be explained. A cross B is equal to what? Here A is 1, 2, 3, B is equal to 4, 5. Then A cross B is what? 1, 4, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5. B cross A is what? First you take elements from B. 4, 1, 4, 2, 4, 3, 5, 1, 5, 2, 5, 3. And finally, we have obtained this type of result. If number of elements in the set is M and number of elements in the set N, the number of elements in the set A cross B is what? M into N. 3 into 2. So n of A cross B is equal to n of A into n of B. Okay. So So this type of representation or all these pair within this bracket are represented by a point. This type of point 3, 4. Okay. This number 1 is representing the number which is lying on x-axis. 1, 4. First one for x-axis, second one for y-axis. X-axis. This for y-axis. Clear? 3, 4. 3 on x-axis. So first number on x-axis, second number on y-axis. Clear? So that is all about the beginning part of this chapter, relation and function. There are two terms, relations. We know what about relation, what relation is and what function. Okay, we are well aware of this word function. So let us discuss what are the meaning of relations and functions for this chapter. Okay, a simple question here. Ordered pair or Cartesian pair or Cartesian product or cross product. You are given any two sets and whose cross product was calculated here. We don't know about the two sets. Anyway, here x by 3 plus 1 comma y minus 2 by 3. This is a point. Okay, like this 3 comma 4. Okay, or x comma y. Anyway, first number is represented for x, second number for y. So here first number is what? This one, x by 3 plus 1. Second number y minus 2 by 3. Here also first number 5 by 3, second number 1 by 3. So these 2 points are same, or these 2 pairs are same, which means what? X by 3 plus 1 is the first number on this pair. So this is represented for the number corresponding to x-axis. This lies on y-axis. Similarly, x-axis, y-axis, isn't it? When these 2 pairs are same, which means what? The first number x by 3 plus 1 will be equal to first number of second pair 5 by 3. So x by 3 plus 1 equal to 5 by 3, isn't it? X by 3 plus 1 equal to what? 5 by 3. Then x by 3 equal to what? 5 by 3 minus 1. Clear? Plus 1 becomes minus 1. Or x by 3 equal to 5 by 3 minus 1 by 1. We have to cross multiply, isn't it? 3 into 1, 3. 5 into 1, 5. 1 into 3, 3. That is 2 by 3, isn't it? 5 minus 3, 2. 2 by 3. Here, x by 3. You can cancel these 2 3's. 3, 3 are cancelled. So, what? X is equal to 2. Isn't it? X is equal to 2. We have to find both x and y. So, first number x, the value of first number x is obtained. Similarly, y minus 2 by 3 is equal to 1 by 3. Y minus 2 by 3 is equal to 1 by 3. So, y is equal to what? 1 by 3 plus 2 by 3. 1 by 3 plus 2 by 3. 3 is common here. 1 plus 2, 3. So 3 by 3, 1. So y is equal to 1. Therefore, values of x and y, x is equal to 2, comma y is equal to 1. This is the answer. Very simple, isn't it? So you can equate 2 points. If these two are equal, x coordinate of first point and corresponding x coordinate of second coordinate will be equal. Similarly, y coordinate of first point and y coordinate of second point will also be equal. Therefore, you can find values of x. And another simple question. Here A is given as set minus 1, comma 1. Then you are asked to find the value of A cross A cross A. It's very simple. Firstly, we are finding A cross A. What is A? Is equal to set minus 1, comma 1. Once again A minus 1, comma 1. Okay. Then what will be A cross A? A cross A is equal to set minus 1 minus 1, minus 1 1, 1 minus 1, 1 1. Right. This is A cross A. How many elements in A? 2. This A 2. Then what will be the number of elements in A cross A? 2 into 2, that is 4. 1, 2, 3, 4. Right. So minus 1, minus 1, minus 1, 1, 1 minus 1, 1, 1. Okay. Then what will be A cross A again cross A? That is A cross A is this one. That is A cross A is minus 1. A cross A cross A. A cross A is 1. Once again A is equal to what? Minus 1, 1. Then what is A cross A cross A? A cross A cross A. A cross A is equal to minus 1, minus 1, minus 1, 1, 1, minus 1, 1, 1. Cross A. A is minus 1, 1. Then we can take it as minus 1, comma, minus 1, minus 1, comma, minus 1, minus 1. Right. Then minus 1, comma, minus 1, 1, comma, minus 1, comma 1, minus 1, comma 1, minus 1, then minus 1, comma 1, minus 1, comma 1, this one, comma 1, comma minus 1, 1, comma minus 1, this minus 1, 1, comma minus 1, 1, comma minus 1, 1, then 1, comma 1, minus 1, comma 1, comma 1, 1, isn't it? Then this can be written as minus 1, minus 1, minus 1, like this. Minus 1, minus 1, minus 1 within these brackets. Similarly, minus 1, minus 1, 1, minus 1, 1, minus 1, minus 1, 1, 1, 1, minus 1, minus 1, 1, minus 1, 1, 1, 1, minus 1, 1, 1, 1. So this is A cross A. Very simple. First you consider this as an element. Minus 1, minus 1, then this minus 1. This minus 1. Second minus 1, minus 1, this one. Like this. Minus 1, minus 1, minus 1, 1. Similarly, minus 1, minus 1, minus 1, minus 1, minus 1, 1. This question says about A cross B as set AX, AY, BX, BY. Here, capital A and capital B are two sets which are unknown. They are not given here, but you are asked to identify these two sets A and B. So, your aim is to find out the sets capital A and capital B. Here, A cross B is given. By looking here, AX, first number from A, capital A. This from capital A. This from capital A. From capital A. From capital A. That is what A cross B. So second number from capital B. From capital B. From capital B. From capital B. So by looking here, we can take capital A is equal to what? A, comma, A, comma, this A, comma, B, comma, this B. But in the last chapter, we learned that what elements of a set need not be repeated. So here A is repeated twice. Similarly B. So repetition is not allowed while representing a set. So we are removing each A and B from the set A. So what? A comma B. So A is equal to what? This one. Similarly, set B is equal to what? Second element of the cross product x, comma, y, comma, x, comma, y. Similarly, this is simplified as x, comma, y. So, set A and B are obtained. Okay, the question is here. A is equal to set 1, 2. B is equal to set 1, 2, 3, 4. And C is equal to set 4, 6. Find A cross B intersection C. Firstly, we are finding B intersection C. What is B intersection C? Common elements from both B and C. B this one, C this one, which are common 4. Okay, 4 is the common. So B intersection C is 4. Then A cross B intersection C. What is A? A is equal to set 1, 2. B intersection C is equal to set 4. A is equal to set 1, 2. B intersection C is equal to set 4. Then what is A cross B intersection C? 1, 4. Then 2, 4. 1, 4, 2, 4. So this is A cross B intersection C. How many elements in A? 2 elements. How many elements in B intersection C? 1. So total number of elements in A cross B intersection C means 2 into 1. That is 2 elements. You are given two sets, capital A and capital B. Capital A contains 3 elements and B contains 4 elements. What will be A cross B? A cross B is equal to set. How many elements will be there? 3 into 4, 12 elements. 1, 3, 1, 5, 1, 7, 1, 8, then 2, 3, 2, 5, 2, 7, 2, 8, 3, 3, 3, 5, 3, 7, and 3, 8. There will be 12 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements. Okay. So A cross B is a set consisting of 12 elements. A is a set, B is another set, A cross B is another set, isn't it? So because what? Set bracket is used here. So this itself a set. And now I am taking a subset of this A cross B, selecting a subset of A cross B. What do you mean by subset? Subset is a part of the set, isn't it? Or subset is made up by some elements of the given set. So you can choose any of the elements A cross B and you can frame another set which is called as what? Subset of A cross B. Now I am taking a set by selecting some elements from here. Here I am taking 1, 3. This 1, 3. This is my choice, okay? Because I am framing a subset by using some of the elements of A cross B. So 1, 3 is my number, my choice. So I have taken 1, 3 here. Your choice may be different, okay? So 1, 3. Then next one 2, 5. I like this number because I took this number or I selected this number here. This is my number. These two are my numbers. Then next one is this one 3, 7. Okay, 3, 7, and closing the set. Actually, this is a small set and all elements of this set can be seen in this big set. Therefore, this small set is considered as a subset of this big set. This concept was learned from the first chapter. Okay, what does subset mean, right? So clearly this small set, I name this set as capital R, for example, capital R. So what is capital R? Capital R is a small set which is made by sum of the elements of A cross B. So that is capital R is equal to 1, 3, 2, 5, 3, 7. Look at each element of this capital R. 1, 3. Can you identify any type of relationship between this 1 and this 3? This 2 and this 5? This 3 and this 7? Can you imagine any relationship between these two numbers? This one is belonging to x-axis and this 3 is to y-axis. That's okay. But I am asking you, can you identify any relationship between this 1 and this 3? Same relationship can be seen here and here also. Okay. See, this number is 1. This number is 3. What about the double of this one? That is 2. Okay. Then you add 1 to this double. Here double of 1 is 2. 1 plus 1, 2. Plus 1, 3. That is double plus 1. Double of first number plus 1. That is 3. What is double of 2? 4. Plus 1, 5. Double of first number is 3. Double of 3, 6. Plus 1, 7. Okay. So this is a common relationship which we have seen between the elements of this set capital R. Okay. That is, this capital R can be rewritten as what? All the elements of the set are of the form x comma y, isn't it? X comma y. First number x, second number y. Okay. First number x, second number y. X, y. So x, y. Such that, what about this y? This is y. What is y? Double of x. Double of x means 2x plus 1. Clear? This is a set builder form of this roster form. This is set builder form. We have discussed this term in the first chapter. Okay, set builder form or rule method. So these two sets are same. Clear? So double of 1, that is 2, plus 1, 3. Double of 4, double of 2, 4, plus 1, 5. Double of 3, 6, plus 1, 7. So when you search the number with this property, only these 3 numbers are available from A cross B. So now we have seen a particular type of relationship between x and y. Which type of relationship? This relationship 2x plus 1. Okay. So this set is named as what? Capital R. That is, what is our name of this chapter? Relations and functions. This is the relation. Therefore, this R is represented as the relation. Relation R. Relation. Relation R is equal to set 1, 3, 2, 5, 3, 7. This is my opinion. Here double of first number plus 1 is my choice. Similarly, you can select your own choices. So there will be different relations. This relation is only an example. You can create different types of relations. Many types of relations. That is, in A, number of elements in A. Suppose here 3 elements. Let us take it as P elements. Number of elements in B. 1, 2, 3, 4 elements. Let it be Q. Okay. Number of elements in A cross B is equal to what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements. That means 3 into 4, 12. That is P into Q. P into Q, PQ. N of A cross B is equal to PQ. then total number of relations or total number of relations is 2 raised to p into q. 2 raised to p into q. What about here p? 3, here 4. 3 into 4, 12. So p into q means 12. 2 raised to 12. What is 2 raised to 12? 2 raised to 12 means what? 2 into 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 2. How many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 raised to 12 means multiply to 12 times. 2 into 2, 4, into 2, 8, into 2, 16, into 2, 32, into 2, 64, into 2, 128, into 2, 256, into 2, 5. Okay, anyway, that much relationship can be obtained or can be seen by using this A cross B. Very large number of relationship can be taken from this A cross B. Okay, this is only an example. You can search different types of relations from here. So anyway, you just identify what do you mean by the term relation. So to identify relation from the set capital A and capital B, first you have to identify A cross B. Then you can select different numbers with your own choices and you try to identify the relationship between x and y. X means first number, y means second number. So in this example, a relationship is taken as y equal to 2x plus 1. 2x means double of x, then plus 1. Okay, so now we are entering into our chapter relations and functions. So I think you are all well about the term relations. Two sets A and B are given. A is equal to set 0, 1, 2, 3. B is equal to set 0, 1, 4, 9 and 10. Then A cross B is what? A cross B is 0, 0, 0, 1, 0, 4, 0, 9, 0, 10. 1 0 1 1 1 4 1 9 1 10 2 0 2 1 2 4 2 9 2 10 3 0 3 1 3 4 3 9 and 3 10. How many elements in A cross B? 1 2 3 4 1 2 3 4 5. So 4 into 5 20 elements will be in A cross B. Then let us take a relation from A cross B. Relation R. I am selecting some of the elements from A cross B, or I am making a subset of A cross B with some properties. Okay, here I am taking 0 0. Then you think, why do I take this number 0 0? Then now I am selecting 1 1. Then you think, is there any relationship between first number and second number? Here 0 0, here 1 1. Second number 2 for this one. 1 1 is this one, 2 for this one. Next number is 3 9 and closing this. This is a subset of A cross B and I am saying that this subset is a relation defined from A to B or defined on A cross B. A cross B. So R is equal to 0 0 1 1 2 4 3 9. Can you identify any relationship between these two numbers? Here 0 0, they are same. Okay, same or equal. Suppose this is a relation equal or same. 0 0 same, 1 1 same, 2 4 are they same? No. So this is not the relation. Then you think any another criteria which satisfy these two elements? What about 0 square, 0 square is 0. 1 square, 1. 2 square, 4. 3 square, 9. Yes, so square is the relation. Square. So we can convert this roster form into set builder form as what? Set x comma y such that y square equal to x. Y square, y, oh no, such that y equal to x square. Y, suppose y, here y is 9. What is 9? 3 square, x square. This is x, it is y. What is 4? That is y. 2 square, x square. Y equal to x square. So this is the relation. So on the same way, we can define several relationships. How many relationship? 2 raised to 20. 2 raised to 20 relationship. 2 into 2 into 2 into 2 into up to 20 times. Okay. Then here 0, 0, 1, 1, 2, 4, 3. Here, which are the first values? 0, 1, 2, 3. These are the first values. 0, 1, 2, 3. 0, 1, 2, 3. Okay. Here 0, 1, 2, 3. This is the first value of the relation. This first value is taken as domain of capital R, domain of the relation. So first values are called as, set of first values are called as what? Domain. Domain is represented as domain D of relation, D of R, domain of R. Similarly, what are the second numbers? 0, 1, 4, 9. 0, 1, 4, 9. These are the second values 0, 1, 4, 9. So it is taken as range of R. So what is range set? Range set is a set with elements, second elements of the relation. Second elements means what? Set of y values, x comma y, set of all y values, that is range set of R. Clear? So domain and range. Once again listen here, A and B. Now I am taking these two sets with arrow marks. Here this circle represents for the set capital A and this circle for capital B. And A cross B is mentioned here and this relation R is taken from A to B. Relation R. What is the relation R? 0, 0, 0, 0, then 1, 1, 1, 1, 2, 4, then 3, 9. Clear? 3, 9. So this type of representation is called what? Arrow diagram. A or arrow or arrow. Arrow means this one. Arrow or arrow diagram. Arrow diagram. So a relation can be represented by using arrow diagram. So this is the representation of this relation. Here, what is domain? Domain means first number 0, 1, 2, 3. That is first number 0, 1, 2. The domain is a set of elements from which arrow mark is begun or arrow mark is started. So what is domain? Domain is a set of elements from which arrow mark is started. And range means what? 0, 1, 4, 9. 0, 1, 4, 9. So range set is a set of all elements to which arrow mark is ending. So 0, 1, 4, 9. That is domain and range. Then the entire set or the full set B. This full set B is called as codomain. Codomain. Codomain means the second set. So there are three common words here: domain, range, and codomain. What is domain? Domain is a set of all elements from which arrow mark is started. Arrow mark is started. Here, this is first set. In this question, this is first set. Here it is noted that domain set need not be first set. Sometimes it may be first set, but there is no compulsory to become the domain as the first set. Okay, sometimes it may be true, otherwise need not be true or false. 0, 1, 2, 3. So, this is the first set. 0, 1, 4, 9, 10 is the second set. 0, 1, 2, 3. Set 0, 1, 2, 3 is what? Domain of the relation. 0, 1, 4, 9. The set of all elements to which arrow mark is ending. That is 0, 1, 4, and that is range of capital R relation. And this full set B, capital B, is also called as what? Codomain. So, domain, range, and codomain. These are the three words connecting this chapter. Question: find the domain and the range of the relation capital R defined by capital R is equal to set x comma x plus 5 such that x belongs to the set 0, 1, 2, 3, 4, 5. Here relation is explained or the relation is given in set builder form. And what is relation? X comma y, isn't it? X comma y. So y is what? X plus 5. First number x, second number y. Isn't it? So second number is taken as what? Y. What is y here? X plus 5. So this is a relationship. And you are allowed to take values from this set. X belongs to 0, 1, 2, 3, 4, 5. Okay, so let us take this relation in set builder form. You can take x values from this set. The first value for x is what? 0. So you put 0 here, 0, comma, then 0 plus 5. Okay, 0. So take x as 0, 0, comma, x 0, 0 plus 5, then 1. 1 comma 1 plus 5. Okay, then 2 comma 2 plus 5, right? Then 3 comma 3 plus 5, then 4 comma 4 plus 5, then 5 comma 5 plus 5. That's all. Is equal to what? 0 comma 0 plus 5, 5. Then here 1, 6, 2, 7, 3, 8, 4, 9, 5, 10. So you are asked to find domain and range. Domain of capital R. What is domain? Set of first elements 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4 and 5. Say 0, 1, 2, 3, 4 and 5. Then what is range? Range of capital R. Range of capital R second elements 5, 6, 7, 8, 9, 10. So these are the domain and range of the given set, of the given relation. Okay. The relation capital R is equal to set x comma x cube such that x is a prime number less than 10 in roster form. What is a prime number? We know that prime numbers, suppose let it be p, prime numbers less than 10. Least prime is 2, then 3, 5, 7. Okay, up to 10. Least prime is 2, then 3. 4 is not a prime. because 4 can be split as 2 into 2. 5 is a prime, 6 is not a prime, 7 is a prime, 8 not a prime, 9 not a prime, 9 not a prime. Why? 3 into 3, 9. Then, okay, then up to 10, these are the prime numbers. So you can select these are as x values. Then relation is equal to what? Set x comma 2 comma x cube 2 cube, then 3 comma 3 cube, 5 comma 5 cube, 7 comma 7 cube. So relation R is taken as set 2 comma 2 cube, 3 comma 3 cube, 5 comma 5 cube, 7 comma 7 cube. That is equal to set 2 comma 2 cube, 2 into 2 into 2, that is 8. 3 comma 3 cube, 3 into 3 into 3, 27. 5 comma 5 into 5 into 5, 125. 7 comma 7 into 7 into 7, 7 to 7, 49 into 7, 343. So this is the relation in roster form. Okay, here set A is equal to 1, 2, 3, 4, 5, 6, 7, etc. up to 40. R is given us in a settable form x comma y such that 3x minus y equal to 0. This is a relation connecting x and y, where x comma y belongs to A. Find its domain, range and codomain. So you can take x values from here, then you will get y values which is also belonging to this A. So now if you got an answer 15, you cannot take that answer because what you are allowed to take numbers from 1 to 14 only. 15, 16, 17, etc. are not allowed. Okay. Here R is equal to what? Or what will be A cross A? A is equal to 1, 2, 3, 4, etc. up to 15. Once again A. Here A is equal to set 1, 2, 3, etc. up to 14. Again A is equal to 1, 2, 3, etc. up to 14. Then what will be A cross A? That is 1, 1, 1, 2, 1, 3, 1, 4, etc., etc., etc. Finally, 14, comma 14. Right. There will be different numbers. That is 14 into 14, 196 numbers will be there. 196. So that is A cross A. Then you can select some numbers from A cross A which satisfies 3x minus y equal to 0. See, that is R. R is equal to set. This is our ability to select some numbers from A cross A. This is your ability. Okay. I am taking a number from, that is button 3. Here, 1, 3 is here. You substitute, this is x, it is y. You substitute x here as 1, that is 3x minus y equal to 0. So x is 1, y equal to 3. X is 1, 3 into 1 minus y is 3. That is 3 into 1, 3 minus 3. What is that? 0. Okay. So 1, 3 is possible. Then if you take 1, 4, 1 comma 4, then substitute here 3 into 1 minus y, that is 4. 3 into 1, 3 minus 4. Is it 0? No. No, not possible. So 1, 4 is not possible. Then what about 2, 6? 2, 6? Yes. 3x minus 5, that's 3 into 2 minus 6. 6 minus 6 equal to 0. So 2, 6 is possible. Then what will be next number? Yes, 3, 9. Okay. 3, 9. 3 into 3, 9. Minus 9 equal to 0. Next number, 4, 12. 3 into 4, 12 minus by 12 equals 0. This is multiple of 3, isn't it? Very clear. 1, 3, 2, 6, 3, 9, 4, 12. Then next number 5, 15, isn't it? But 15 is not here. So you cannot take this one and you can close here. So this is the relation in roster form instead of this set builder form. These two sets are equal sets, isn't it? 1, 3, 2, 6, 3, 9 and 4, 12. Then you are asked to find what? Domain, range and codomain. Then what is domain? Domain is equal to first element 1, 2, 3, 4. 1, 2, 3, 4. Set 1, 2, 3, 4, isn't it? Then range is equal to set second 3, 6, 9, 12. 3, 6, 9, 12. 3, 6, 9, 12. Then codomain means what? A full second set. That is A cross A. This set, isn't it? 1, 2, 3, 4, etc. up to 14. That is A itself. So these are domain, codomain, and range of a relation. Okay. So these are all about relations. Actually, this is a continuation of first chapter sets. Now we are winding up this chapter here, and we will meet again with another topic in another class. Okay, thank you.